All right, ready to dive into some really cool AI research.
Always.
Today, we're looking at this paper about large language models, LLMs, and how to, well, make them think better.
Get them to reason more effectively.
Yeah, exactly, because right now, they're kind of like,
Students who cram for tests.
yes, they memorize everything, ace the practice quizzes, but then
They see a problem they've never encountered before.
they totally blank.
That's a great way to put it.
Yeah.
And it's a major challenge for LLMs.
So this research, it tackles that head on. They call their technique test time training, or TTT.
It's about giving LLMs a boost in their reasoning ability, right when they need it most, during the actual test.
And they tested it on, get this, the Abstraction and Reasoning Corpus.
The ARC, yeah, it's notorious. A collection of super tough visual reasoning puzzles.
And with TTT, they achieved almost a 25% accuracy improvement.
Which is huge, especially considering they even beat some of the neurosymbolic AI approaches.
Neurosymbolic AI?
Combining neural networks and good old-fashioned symbolic reasoning.
That sounds fascinating. Okay, so before we get lost in the technical details, can you give us a sense of what these ARC puzzles are like?
Sure. Imagine like a grid, right?
Yeah.
With rows and columns.
Like a spreadsheet.
Sort of. But instead of numbers, it's filled with shapes and patterns. And the AI has to figure out, well, the rule that transforms one grid into another.
So if the first grid has a blue triangle, and the second grid has the same triangle but upside down.
The rule might be flip the shape vertically. But it's not always that simple. The transformations in ARC can get really complex.
Like?
Figuring out the shortest path between 2 points, or even applying concepts like gravity, abstract stuff.
No wonder traditional LMs struggle. So
Right.
TTT, it obviously works, but what's the secret sauce? The paper goes into detail about what makes it so successful.
Well, there are 3 key ingredients. Initial fine-tuning, augmenting the test data, and then something called per-instance training.
Okay, let's break those down. Starting with fine-tuning, that's like giving the LLM a good warm-up before the big game.
Exactly. They fine-tuned the LLM on tasks that are similar to the ARC benchmark, instead of just throwing random stuff at it.
So it's had some practice with similar puzzle logic, even if the puzzles themselves aren't identical.
Right. And this turned out to be really important for TTT to work its magic later on.
Makes sense. So what about augmenting the test data? That sounds a bit sneaky.
It is. They actually use the test input to create more training data on the fly.
Wait, hold on. Using the test to create more training data? How does that even work?
They get clever with it. For example, if a puzzle has a few example input-output pairs, they'll remove one, treat it as a mini-test, and use the others as training.
Oh, I see. So they're like remixing the existing examples to create more training data.
Exactly. Plus, they apply these rule-based transformations like rotations, flips, even color changes to create even more variations.
So they're not just giving the LLM one example, but showing it the same puzzle logic from different angles.
Right. It's kind of like how humans learn. We don't just memorize one example. We try things out in different ways to truly get it.
Like practicing a guitar chord in different positions up and down the neck.
Exactly. It's about understanding, not just memorizing.
Okay, that makes sense. So we've got fine-tuning, augmenting the test data, and then the third ingredient is this per-instance training.
Right. Instead of updating the LLM once for all the test puzzles, they actually adapt its parameters for each puzzle individually.
Oh, wow. So it's like each puzzle gets a custom-tailored study guide.
That's a great way to put it. Very personalized learning.
Okay, I'm seeing how these pieces fit together, but how does TTT actually learn during the test?
Well, they tried 2 main approaches. Test time in-context learning and test time end-to-end learning.
Those sound pretty technical.
They are, but bear with me. In-context learning means giving the LLM a few example input-output pairs during the test itself.
So it's like having a cheat sheet with a couple of worked out problems.
Kind of. End-to-end learning, on the other hand, is more direct. No examples, just input and output.
Like trying to solve a math problem without seeing any examples first.
Right. And guess what? The in-context approach with the examples worked way better.
So even though the LLM has been fine-tuned, it still benefits from seeing a few concrete examples before tackling the puzzle.
It seems that way. And there's another interesting thing about those examples.
Tell me?
They found that including the examples in the loss function during training, even though they're already solved, actually improved performance.
Wait, so you're saying the model gets better by revisiting stuff it already knows? Like, what's the point of that?
It is a bit counterintuitive, but it works. It seems like forcing the model to think about those solved examples helps it refine its understanding.
Fascinating. So it's like a student reviewing their old homework before a test, even if they aced it the first time.
I like that analogy.
Okay, so we've got the augmented data, in-context examples, and this curious revisiting of solved problems. But how does the model actually update itself during all this? Updating an entire LLM for every single test puzzle seems impossible.
You're right, it would be incredibly inefficient. That's where this technique called low-rank adaptation, or LoRA, comes in.
Laura.
It's a way to update only a small subset of the model's parameters, the ones most relevant to the task.
So it's like giving the LLM a targeted upgrade instead of overhauling the whole thing?
Exactly. And it makes the learning process way faster during the test.
Smart. And I read that they even experimented with quantized LoRA. QLoRA. What's that about?
It's like compressing the updates to save memory and make things even more efficient.
So they're making these LLMs smarter, and the process of making them smarter. Impressive. All right, so we've covered how the model learns during the test, but then there's this whole other stage called augmented inference, which sounds cool. What's that about?
It's about getting multiple perspectives on the solution. After TTT, they actually run the model multiple times, each time applying those geometric transformations we talked about.
So like rotating or flipping the output?
Yeah. It's like having a team of experts each looking at the puzzle from a different angle.
So they're trying to get a more well-rounded view of the solution, but then how do they pick the right answer?
They have this two-stage voting system.
Voting. Like a democracy of AIs.
Kind of. In the first stage, predictions are grouped by the transformation. So all the rotated 90 degrees predictions are together and so on. Then they pick the top 3 most frequent predictions from each group.
Okay, so it's like a primary election, narrowing down the field.
Exactly. And then, in the second stage, those top predictions from each group go head-to-head. The top 2 winners are the final answers.
Wow. It's a primary election followed by a general election for AI puzzle solutions. Amazing.
And this voting strategy led to huge improvements in accuracy compared to just running the model once.
So it's all about strategy, giving the LLM more information and then using it wisely. Okay, we've talked about the core challenge, all these clever tricks with TTT, but we haven't talked about pre-training yet. What happens before any of this TTT magic?
Pre-training is crucial. It's where the LLM gains its initial knowledge and understanding.
But how do you pre-train an LLM for something as abstract as reasoning? It's not like you can just give it logic textbooks.
That's the challenge. They explored 3 main approaches: using existing task generators, prompting another LLM to make new ones, and then, you guessed it, applying those geometric transformations.
Okay, let's take those one by one. What are these task generators you mentioned?
There's this project called RERC that has a special language for creating ARC-like tasks. And it has a bunch of ready-made generators.
So like recipes for making different kinds of puzzles.
Exactly. They can use these to create tons of new training examples for the LLM.
And prompting another LLM to create tasks, that's got to be experimental.
Oh, yeah. They actually used GPT-4 to try to generate new task generators. They gave it some examples and also some descriptions of what the tasks should be like.
So they're like, hey, GPT-4, look at these puzzles, see how they work. Now go make some new ones.
Pretty much. They even did a 2-stage thing where they first asked GPT-4 for a description and then fed that back to it, along with examples to generate a new generator.
AI generating AI training data. Wow.
It is pretty wild.
Okay, and the third approach was our old friends, the geometric transformations.
Yep. They use them on the input, the output, or both to create variations of existing tasks.
So it's all about exposure, showing the LLM as many variations as possible, both during training and testing. But I'm curious, what worked best? Did using another LLM to generate tasks lead to, like, superintelligence?
I wish. But actually, it kind of backfired. Including those LLM-generated tasks actually hurt performance.
Seriously? What happened?
It seems the quality just wasn't there yet. The tasks weren't challenging enough. Or maybe GPT-4 just needs more practice as a puzzle designer.
So even though LLMs are amazing, they're not quite ready to replace human ingenuity when it comes to making training data?
It seems not, but it raises some interesting questions about AI generating AI training data. It has potential, but there's still work to do.
Right, like that saying, garbage in, garbage out. If the training data is bad, the LLM won't learn to reason well. Okay, so we've covered pre-training, the unexpected hiccup with LLM-generated tasks. But now for the big question. Did TTT actually work? Did it boost LLM reasoning on the ARC benchmark?
Time for the big reveal!
I'm on the edge of my seat.
They tested their approach on the full ARC benchmark. And with TTT alone, their fine-tuned LLM, which had 8 billion parameters, by the way, reached 47.1% accuracy on the public validation set.
So almost half of these super tough puzzles, just with TPT. That's incredible. But I
Yeah.
bet they didn't stop there.
You know it. They also combined TTT with the best existing method at the time, which was called BARC.
BARC.
Yeah, it used a combination of neural networks and something called program synthesis, a very different approach.
So they combined the adaptive power of TTT with the more structured reasoning of program synthesis.
Exactly, and the results were amazing. They achieved 61.9% accuracy on the full ARC benchmark.
Whoa, 61.9%.
That's right. They actually matched average human performance on these incredibly difficult puzzles.
That's groundbreaking. So TTT not only improves individual LLMs, but it can also be combined with other approaches for even better results. Does this mean we've solved AI? Are we on the verge of AI that reasons as well as humans, or even better?
Hold on. While this is huge, it's not quite artificial general intelligence. The best humans score almost 98% on ARC, so there's still a way to go.
Okay, so we've reached base camp, but the summit's still far off.
A good analogy. But this finding does challenge a common assumption in AI. For a long time, people thought symbolic reasoning, the kind used in traditional programming, was the only way to solve these kinds of problems.
But TTT suggests that neural networks, if trained and adapted in the right way, can learn to reason more like humans do.
That's what makes this so exciting. It opens up a whole new path for developing powerful and flexible AI.
It's like we found a hidden talent within these LLMs. You're not just mimicking human language, they have the potential to actually understand and reason. And TTT might be the key to unlocking that potential. All right, so from struggling students to almost human-level reasoning, this has been quite a deep dive. But before we wrap up, where do we go from here? If TTT works this well for visual reasoning, where else could it be applied?
That's the million-dollar question, and we'll be diving into those possibilities right after a quick break.
Sounds good. We'll be right back to continue our exploration of test time training.
Welcome back. We were just talking about the potential of TTT beyond those visual reasoning puzzles.
Right, because if it can handle something as abstract as ARC,
It makes you wonder what else it can do.
exactly, what other fields could benefit from this kind of on-the-fly learning?
Well, the possibilities are huge. Think about, like, medical diagnosis.
Okay.
An AI that analyzes patient data, symptoms, all that.
Uh-huh.
But then with PTT, it could adapt to new information in real time.
So it's not limited to what it learned during training.
Right. Like, imagine a rare condition it's never seen before.
It could still figure it out.
Potentially, yeah. Constantly learning and improving. It could revolutionize personalized medicine.
That's amazing. What else?
Scientific discovery. Researchers are always dealing with tons of data, looking for patterns.
Right?
TTT could help AI analyze that data and come up with new hypotheses.
Like an AI research assistant constantly learning alongside scientists.
Exactly. And think about education.
Okay.
AI tutors that adapt to each student's learning style, providing personalized instruction.
So every student gets a custom-designed learning experience.
Yeah. TTT could make that a reality.
That's powerful.
It's not just about making AI generally smarter. It's about making it more specialized, more adaptable.
More tailored to the specific needs of a situation.
Exactly. And this continuous learning aspect of TTT, it really changes things.
We're not talking about static tools anymore.
No, it's more like,
Dynamic partners.
yeah, partners that can learn and solve problems with us.
That's a huge shift. But, we have to talk about the risks, too.
Of course. Any powerful technology comes with risks.
If we're making AI this adaptable, this capable of learning, what if it becomes unpredictable or even dangerous?
That's why responsible development is so important. We need to ensure these AI systems are aligned with human values.
So it's not just about making AI smarter,
It's about making it safer, more beneficial for humanity.
keeping it a tool that serves us, not the other way around.
Exactly. TTT is a powerful reminder of that. AI is a tool, and we need to use it wisely.
This conversation has been amazing. We've covered so much ground.
The potential of TTT is really mind-blowing.
It is. But before we wrap things up, I want to leave our listeners with a question.
All right, fire away.
If TTT can unlock this level of reasoning in LLMs, what other hidden talents are we missing? What other problems might AI be able to solve with this kind of test time boost?
That's a great question. The possibilities are endless. Think about language translation, for example.
Okay.
An AI that can adapt to different dialects and slang in real time.
Wow, that would be incredible.
Or creative writing. An AI that learns an author's style as they write and becomes a true co-creation partner.
My mind is blown.
It's a vast, uncharted territory. And TTT is the compass guiding us toward a future where AI is not just intelligent.
But adaptable, creative, constantly evolving.
Exactly, and who knows, maybe one of our listeners will be the one to make the next breakthrough.
To push the boundaries of TTT even further.
Absolutely.
That's an inspiring thought. We've reached the end of our deep dive into test time training.
Fascinating journey.
It has been, and we hope you've enjoyed it as much as we have. Remember to keep those minds curious, those questions coming, and those imaginations firing, because the future of AI is being shaped right now, and you might just be the one to write the next chapter.
You know, it's really amazing to think about all the things PTT could change.
It really is groundbreaking stuff.
And not just in terms of like raw problem-solving power.
What do you mean?
Well, TTT, it could totally change how we think about AI, even how we interact with it. Okay, I see where you're going with this.
Right now, we see AI as these, tools, right?
Like a super-powered calculator or a really smart search engine.
Yeah, exactly. But with TTT, it becomes more like...
A partner.
Yes, a collaborator. Something that learns and adapts alongside us.
Instead of just giving us answers.
It could help us ask better questions, explore new ideas, maybe even challenge our own assumptions.
Imagine that. It could make the whole process of discovery, whether it's science or art or anything, much more dynamic.
Way more interactive.
Yeah. We're not just using AI, we're working with it.
That's a huge shift. From AI as a tool to AI as a creative partner.
And who knows what amazing things we could achieve together. This is really just the beginning.
Well, folks, it seems we've reached the end of our deep dive into test time training.
It's been a fascinating exploration.
It really has. We've covered so much. The challenges, the potential. It's mind-blowing.
From the technical nitty-gritty to these big philosophical questions about how we interact with AI.
And I don't know about you, but I'm feeling incredibly optimistic.
TTT shows us that AI is capable of so much more than we thought.
It's not just about bigger models or faster processors. It's about finding smarter ways to use the technology we already have.
And it's about pushing the boundaries of what we thought was possible.
This field is constantly evolving. There's always something new to discover, some new challenge to tackle.
And that's what makes it so exciting.
Absolutely.
Yep.
And who knows, maybe one of our listeners will be the one to make the next breakthrough.
To take TTT to even greater heights.
To uncover even more of AI's hidden talents.
Exactly. The future is full of possibilities.
So as we sign off, we want to encourage you to keep asking those big questions, stay curious, and never stop exploring. Because the future of AI is still being written, and it's up to all of us to shape it. Thanks for joining us on this deep dive, and until next time, keep those minds engaged.